So what's the hybridization of this carbon?
sp3.
Okay, so what type of orbital is it using in this bond?
Sigma.
What type of orbital? We don't want to confuse orbitals and bonds.
S orbital.
What types of orbitals does an sp3 hybridized atom have?
sp3 orbital.
Yeah, if you're sp3 hybridized, all you've got is sp. So this is a very important table to have in your notes. This is all we've got because we've mixed together all of the original orbitals.
Got it.
So it must be using an sp3 orbital here.
And then it's a sigma bond because they had to have.
That's right, that's right. We'll get to that in a second, but it's good that you're thinking about that. So what type of orbital is it using to bond to the hydrogens?
sp3.
That's right. And what type of geometry will we be taking here?
Tetrahedral.
Right. What type of orbital is the hydrogen using? Well, all hydrogen has is an s orbital. And again, to make the picture simpler, I'm not going to draw the back lobes here. So I'm just going to draw the front lobes. And I'm not going to try to draw all the orbitals here either. I'm just drawing some of the sp3 orbitals. And this carbon as well would use an sp3 orbital. And an sp3 orbital. All right, so yeah, so you were saying, what type of bond is this?
The sigma bond.
Because we got a head-to-head overlap. What type of bond is this?
Sigma.
How about here?
Sigma.
In fact, they're all sigma. Everywhere here we have just head-to-head overlap. So these are all going to be sigma bonds. Just like, so earlier we learned a mechanical method that single bonds were sigma bonds, but now we can kind of see what it means, that these are all sigma bonds. Okay, good. The hybridization of this carbon.
sp2.
What type of orbital do you think it's using in this bond?
sp2.
And here?
sp2.
And here?
sp2.
And here?
P.
Got to be, because it's
Yeah.
only got 3 sp2 orbitals. So it can't use 4 sp2 orbitals, it's got to use 3, and then it's got to have a p orbital left over. And we know we got to use the p orbital here because we know one of these is going to be a pi bond, and pi bonds can only be made out of p orbitals. So the p orbital has to be used to make a double bond or a triple bond, because otherwise it couldn't really be a pi bond. So this has got to be a p. All right, and by the same token, this will be sp2, this will be p, this will be sp2, s, sp2, and s. So let's draw what some of that would look like here. What's going to be the geometry around this carbon?
Trigonal planar.
Right. Well, here's what the sp2 orbitals look like. I won't draw the back lobes again for simplicity, and I won't draw the orbitals over here. So what type of bond is this?
Sigma.
Sigma. Now where's the pi bond coming from?
The p orbitals, which are perpendicular to it.
Right, now we use the idea that p means perpendicular. Remember, this isn't 2 different p orbitals, it's 1 p orbital with 2 lobes. And here are the bonding interactions. That's 2 overlapping p orbitals, which give us a pi bond. So before, we just kind of blindly memorized that a double bond was 1 sigma and 1 pi, but your instructor wants you to be able to draw what the sigma and pi bonds look like. Well, this is what they actually look like. The sigma bond comes from the overlap of these 2 sp2 orbitals, and the pi bond comes from the overlap of the p orbitals. Remember that pi bonds can only come from side-to-side overlap of p orbitals. All right, and we can see here who's going to be stronger, the sigma bond between the carbons or the pi bonds?
Sigma.
Yeah, because it's got the actual overlap. Generally speaking, double bonds are stronger than single bonds. but they're not twice as strong, right? Because when you put in the pi bond, it doesn't add as much extra strength as the sigma bond. That's something that instructors sometimes like to test. All right, we can also draw sp2 orbitals here as well to show these sigma bonds, but then the picture gets very bubbly and confusing. But anyway, this gives you the basic idea of what ethylene looks like, what that picture would be. Okay. This is acetylene. What's the hybridization of this carbon?
SP.
Okay, good. So let's see. What type of orbital is the carbon using to bond to the hydrogen?
SP.
What type of orbital is the hydrogen using?
Sigma. I mean S.
Yeah, it's using a s orbital to form what type of bond?
A sigma bond.
Right. And good. What's going to be the geometry around this carbon?
Linear.
Yeah, and the bond angle?
180 degrees.
Because it's sp. So we can actually draw these in here. Okay, what type of orbital does the carbon use in this bond?
SP.
And how about here?
P.
And here?
P.
That matches up with what we have here. We're going to use the two sps and the two p orbitals. Well, the two p orbitals have to go in this triple bond area so they can make pi bonds. All right. So what type of bond do we have here?
Sigma.
And here?
Sigma.
And here?
Sigma.
What else is there?
There's two pi bonds that are perpendicular to the SP orbital.
So I can draw some p orbitals here. Here's one pi bond. But where can we put the second pi bond?
It'll be going like into the board and coming out.
Yeah, it's hard to draw now, but there's another set of p orbitals coming into the board and out of the board here, and into the board and out of the board here. So those two sets of p orbitals would be perpendicular to each other. And they're also going to have a pi interaction. All right, and that will give us this. We can actually see now why you never see quadruple bonds. We can now see why triple bonds is the most you can have, because there's just no more room for everything else. We've used up all the dimensions here, pretty much. There's only room for one sigma bond and then two pi bonds, and that's it. So we can understand why we never see more than a triple bond. All right, so earlier we just memorized that this would be one sigma and two pi bonds, but your instructor wants you to actually be able to draw those bonds in terms of the orbitals as well. And it takes a lot of work to put all those pieces together. One of the keys is knowing this chart and knowing that something that's sp hybridized actually still has two unhybridized p orbitals. So the general thought process here is first find the hybridization. That tells you the arrangement of the orbitals. And then you can draw in the orbitals that you need in the right geometry and try to show the overlap with other orbitals and figure out what type of bonds you have. And again, don't confuse sp orbitals that overlap to form a sigma bond, or p orbitals that have side-to-side overlap to form a pi bond. There's a difference between p and pi. Does that make sense? How many carbons are in the sp2 hybridization state? Let's figure out how many carbons here we have in an sp2 hybridization state. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. What's the hybridization of this oxygen?
SP2.
That's right, because it has one attached atom, and we should know that since it has no charge, it has 2 lone pairs. So we should be hybridizing 3 orbitals, 2 p's and 1 s. So they didn't ask that on this question on the test, but they could have. They could also ask for the hybridization of a non-carbon. So this would be sp2 hybridized. Right, good.